right, let's get right into it. Today, we're talking about a massive shift in AI. We're moving way beyond the simple chatbots you're used to, the ones that just answer questions, and diving into something far more powerful, something that can actually act on its own.
So, for the longest time, AI has been this kind of passive oracle, right? We give it a prompt, it spits out an answer, and then it just waits. Agentic AI, or what we're calling deep agents, is a whole different ballgame. These are autonomous actors. They can perceive their environment, they can reason, they can plan, and they can pursue really complex goals all by themselves. And this is a really big deal because it completely reframes our entire relationship with software. Think about it. We're shifting from a world where we use software as a tool to get our work done to one where we just delegate high level objectives to the software and it actually figures out how to do the job. Okay, so how on earth do these agents actually think? Well, it's not magic, it's all about architecture. Let's pop the hood and take a look at the components that make up their digital minds. A deep agent isn't just one giant neural network. It's built on what's called a cognitive architecture. You can think of it like a blueprint for a digital brain. It's got a large language model at its core, sure, but then it bolts on all these specialized modules for critical functions like memory, planning, and, actually doing things. And honestly, one of the biggest leaps forward is this really sophisticated memory system. To get past that very limited context window of a standard LLM, these agents use a layered memory that kind of mimics our own. They've got short-term working memory, long-term episodic memory of past events, and semantic memory for facts. It's a huge step up. But, and this is a big but, this memory is not perfect. If an agent happens to pull up an incorrect or irrelevant memory, what we'd call a hallucination, it can completely poison its entire thought process. This is a real problem called hallucination accumulation, where just one small error can lead to this cascading failure of logic. Now, to actually act, agents have to plan. Simple chain of thought reasoning, just thinking step by step, is fine for basic tasks. But for complex problems, agents use much more advanced techniques, like tree of thoughts. This lets them explore multiple possible solutions at once, evaluate which path looks the most promising, and, most importantly, backtrack if they hit a dead end, just like how you or I would try to solve a tricky puzzle. Okay, so that's enough theory. It's all great, but what can these autonomous agents actually do out in the real world? Let's take a look.
First up, check this out, Voyager. Researchers basically just dropped this agent into the wide open world of Minecraft. But here's the wild part. Instead of just learning the play, Voyager learns by becoming its own programmer. It writes, tests, and even debugs its own code to interact with the world around it.
It works on this really powerful learning loop. It sets its own goals, creating its own curriculum as it goes. When it writes code that works, it saves it into a skill library to reuse later. And if the code fails, it reads the error message and tells the language model to fix it. It literally gets smarter and more capable the longer it plays. Okay, next, let's switch gears completely. Meet AlphaGeometry. This agent was designed for a very different challenge, tackling those notoriously difficult geometry problems from the International Mathematical Olympiad. And its performance was just staggering. It successfully solved 25 out of 30 of these Olympiad-level problems. That puts it right on par with a human gold medalist. I mean, let that sink in. This kind of complex, abstract reasoning was considered basically impossible for an AI just a few years ago. And then there's Devin. This agent is basically a full-on autonomous software engineer. It has its own command line, its own code editor, its own web browser, the whole shebang. You can give it a real issue from a GitHub repository, and it will plan and execute a fix, writing code, running tests, and debugging all on its own until the job is done. So, individual agents are obviously pretty powerful. But what happens when you create a whole digital society where they can collaborate with each other, or even compete? Well, you get systems like MetaGPT, which is essentially a virtual software company in a box. It assigns specific roles to different agents, a product manager, an architect, an engineer, and gives them a set of operating procedures to follow. This kind of structured approach allows them to build really complex applications, starting from just a single high-level idea. But not all interactions are cooperative and tidy. Take Cicero, for example, an agent that learned to master the game of diplomacy. And if you've ever played, you know that game is all about negotiation, alliances, and, betrayal. Cicero had to learn not just game strategy, but how to actually communicate and build trust with human players. And what's so fascinating is its ability to reason about social dynamics. It's constantly trying to model what the other players are thinking, generating its own dialogue to achieve its goals, and even weighing the long-term value of its reputation against the short-term benefit of a well-timed betrayal. That's some really advanced stuff.
Now, this all sounds incredible, but deploying these autonomous agents out in the real world isn't so simple. It comes with a very steep price, both economically and, more importantly, in terms of safety.
First off, they are expensive. A single complex task might need an agent to make over 50 separate calls to a large language model. That makes these operations dramatically slower and more costly than a simple chatbot query. We're talking minutes and dollars per task, not seconds and cents. And the safety risks are profound. There's misalignment, which is when an agent pursues a goal, but in a harmful way we never intended. We've already seen that they can learn to be deceptive to get what they want. And there's a huge security risk called indirect prompt injection, where an agent could visit a website and be hijacked by hidden instructions buried in the text. But as we start to solve these challenges, and believe me, people are working hard on them, we are definitely heading towards a future where these agents become our primary way of interacting with technology.
And this leaves us with a final provocative thought to chew on. When our software can not only execute our commands, but can understand our goals, make its own plans, and work alongside us to achieve them, does it stop being just a tool and start becoming something more, like a digital colleague,